and where the user program can end. So that that address actual the storage of the user process can be known as the physical address and the physical address space. So here, according to paging concept, the operating system can divide the user program or the user process into equal sized blocks which are called as the pages. In the same way, the main memory space is also, user space is also divided into equal sized blocks exactly with the size of the secondary memory store, also known as the frames. Generally we thought user program with 100 KB may store in 100 KB size in the main memory. That is mean of that the pages which are having equal sizes. For example, if suppose assume that the particular 100 KB user space program or the process can be divided into 10 blocks of each size, I mean 10 KBs of each page, then totally there are 10 pages must be available in user program of 100 KB, because each page size is 10 KB. So 10 KB into 10 pages, totally 100 KB. In the same way, the physical memory is also divided into equal sized or fixed sized blocks called as frames. Of course, the frame size or the page size. Page refers secondary memory and frame refers main memory. That is the main thing we have to understand, so that the concept of paging is very easy now. So here the division of the physical memory into frames can have the range of always in the 2 powers between 512 bytes to 8192 bytes. That depends on the memory capacity, main memory capacity. So divide of logical memory into blocks already we known as pages. Always the OS has to maintain the statistics about the total number of frames available in the free frames which are available in the main store, because in order to execute user programs after proceeding the loading scheme. So here the OS has to maintain total number of frames which are available in the main store and already user frames as well as already free frames which are available in order to load the user process. So generally to run a user program with n pages size, definitely the OS must find n number of free frames in the main store. Then only the OS can load the user program from secondary store to main store. So here, in order to the actual outcome of the paging concept is paging table. In order to find the, in order to proceed the paging concept, in order to implement paging concept, the OS has to design a data structure which is called the page table. Here, the page table totally contains the number of pages of the user program which are having equal sized partitions. So set up a page table and to translate the logical address to physical address. So generally the process of paging is not only simply designing the data structure or the creating the page table, also with the help of the paging concept, after creating the page table, the OS can translate the logical address space to physical address space, because logical address mean that the user program still in secondary memory, that is called logical address space. So in order to maintain that user program into main memory, it must translate the user logical address space to physical address space. Then only the program can be brought into main store for execution proceedings. So of course the paging concept can suffer from internal fragmentation. So here I will tell you a little bit information about the internal fragmentation. So here internal fragmentation means generally when we copy, for example when OS copies the user program from secondary memory to main memory, what happens is, if suppose my program size is 90 KB for a while, this time my program size is, I write a C program which is having 90 KB, but the secondary memory as well as main store is divided into suppose 10 KB of each block, each page or each frame. So in order to copy the 10 pages, it has to find 10 frames. So already 10 free frames are available and already the user process is loaded into 100 KB of the 10 frame into 10 frames. So totally there is 100 KB, but my program size is how much? 90 KB, but how much space is already allotted? 100 KB. So means 10 frames are available, 10 frames are already allotted, but in the last frame, in the first 9 frames, the user program is occupied totally 9 frames into 9 frames into 10 KB, 90 KB is occupied. Coming to the last frame size is 10 KB, but it is taking how much only, it is taking only because frames are available. There is a totally 100 KB size is available to the user process, but my user program size is 90 KB. So 90 KB is equipped in the 100 KB, but the last frame is not used by the user program. That is called the fragment, that is called the internal fragmentation, because the last frame could not be used by the user process, and which is not used by the current process as well as, and is not allotted to any other process also. That is nothing but the what internal fragmentation. So when the user program is given the space in the main memory which is more than its requirement, then automatically the main memory suffer from internal fragmentation, right. So here, in order to translate the logical address to physical address space, the address generated by the CPU is in the page table divided into two parts. One is called page number, of course, which is index always starting with 0. The index of the page number is available in the page table. So that can have the base address that is available in the physical memory. Phase offset referred by the symbol D, here combined with the base address to define the physical memory address that is sent to the memory unit. The offset is nothing but the total displacement, that is, for example, page number is nothing but 0, 1, 2, 3, 4 like that. So coming to page offset, so page offset means, for example, my program size is 100 KB, it is starting from 0 ending at 99 KB, totally 0 to 99 KB is nothing but 100 KB. So the page offset is nothing but D value represents totally 0 to 99, that is 99. So that is the displacement. Total occupancy of the user process can be termed as the page offset. Now we can see that in this program, I mean in this slide very clearly, address translation scheme, nothing but the paging concept can translate the logical address of the user program to physical address space, so that the process can be start execution by the CPU. Now in the diagram it is very clearly showing the CPU is converting, I mean the CPU with the help of this page table, the OS is converting logical address space to physical address. So in the logical address space, the OS is submitting the page number as well as the page number can be picked from the page table, and the logical address space, I mean the displacement is going to supply by the OS, so that totally the P plus D now becoming the F and D. In always when the user program is in secondary memory, it is referred as page with the page number. When it is going to loaded in main memory, it is termed as the frame, because we know the main memory is divided into, the physical memory is divided into two equal sized blocks called as the frames, the frame number and the offset. Totally the user program can store in the user address space in the shown format, that is F000 that is starting address to some F111 in the hexadecimal format. So this particular diagram is very absolute knowledge gaining for understanding how the logical address space is converting to physical address space using the paging concept via the page table implementation. So this is a small example for paging. See at the left side diagram, I mean on the left side the logical memory is having a number of pages. The user program is divided into equal sized blocks, that is page 0, page 1, page 2, page 3. Totally in the user program there are totally 4 pages indexing 0 to 3. So similarly the page table can have two fields. The first one is page number, the second one is frame number. Similarly, if you come to the right side, rightmost diagram, that is physical memory main store, the main store can have frame number, the first index is the first field is frame number, the second field is pages which are physically loaded in the main store. So the page table, if you look at here, the page table contains page number 0, 1, 2, 3, because how many pages are there in user program? 4 pages which are indexing from 0 through 3. Similarly, in order to load user program with 4 pages, the OS has to find 4 free frames. Of course, we don't know at that time what are the free frames available, because only OS knows it, because OS has the complete statistics about the free frames which are available. So in this case, if you look at the page table, so page 0 can be loaded to frame number 1.